Hello. Today is late. It's 8:50 now. I'm going to follow this guy called Alex Lee. He got a great Java course. There are like 100 of videos. I will just recreate one of his program today. So I will share with my Visual Studio Code. Share. Let's see.
Hey, what's up, guys? Today we're going to be learning about logical operators, a little double pipe and the double ampersand and the exclamation mark. But first, a lot of people are understanding Java a lot better with my course. So if you want to understand Java, you can check out my full Java course linked down below. Let's start learning about logical operators in Java by just making a new Java project. We'll call it logic, hit finish, and then in there, we'll make a class, logic again, with the main method and finish. So there are a lot of different operators in Java. Those are just the little symbols like equals, minus. The ones we're talking about today are the double pipe, the double ampersand, and then the exclamation mark, which are the logical operators. An example of this would be if we have a Boolean variable here, say it's called A, and then we have something that results in true or false on the right. If we just print this out, we will get true because A is set to true and we're printing A. Now let's go one by one through these operators. And let's start with double pipe. I know this looks confusing right now, but it's really, really simple. Double pipe means or. Double ampersand means and exclamation mark means not. Do you read this as true or true? Boolean A is the result of this. If this is true or this is true, then A will be true. So if we save and run this, we'll get true. If this is false, it'll still be true because this one is. Just one of them has to be true. It's or. So if this was or false, again, you can stack these as much as you want. As long as this entire thing ends in true or false, and then each one of these little ones ends in true or false, it'll work. So this will still be true because just one of them is true. If this was false and they're all false, this would be false because it's like false or false or false or false. Well, we didn't see any true. It was not going to work. I'll come back for more examples, but let's move on to and for now. So let's change this to and. Delete this, save and run. This is false. And means both of them have to be true. So if we have true, true, it'll be true. But if just one of them is off, it won't be. And finally, the exclamation mark, it gives you the opposite. So if we put this whole thing in parentheses here, not change this Boolean name to C, to make it a little sequential. Here we can use comparative operators with numbers, and we can start off with something really simple, like is A greater than B? Save and run. We will get false because A is 3, B is 4. This results in false, which is why we get false. Let's practice or, and not on this. So let's say we have this, and we have or true. Boolean C is equal to the result of this entire thing. On the left side, we have false. On the right side, we have true. Either this one or this one can be true, and it'll result in true. Since this one's true, the whole thing is true, which is why when we run it, we'll get true. If this was false, since both are false, we'll get false. Let's try and. For this one, both of them have to be true. So we'll change this one to true. Save and run. Both of them still aren't true. If we say A is less than B, then that would make this side true, which would in turn mean that both of these sides are true. Let's do a not here. This whole thing right here results in true, as we've seen here. A is less than B, and then just this true here. We can take that whole thing and make it not, and then that'll give us false. Or another thing we could do is we could say not this, like if this section is true or some other section is true, maybe say am sad, maybe that's false, and we'll have am sad. And you don't have to make all these weird complications. Usually the simpler the better, but you can stack these. Let's change this to am happy to make sense with the having a good day. And let's, for example, say that is sunny is false. And let's save and run this. We don't get anything printed
This one
out.
is too simple. I will go with the next one.
Have you searched the internet trying to solve your problem of calculating exponents in Java? Well, if you're frustrated and you can't find it, I'm happy to tell you by the end of this video, you'll have a fully working Java program that calculates exponents for you. Let's call it exponents to the power of 2 to get 25. To get the exponent in Java, we can times. No. And that's exactly what I did. We can get rid of this integer here. We can save it, run it. Let's see what happens. And we get 25. Save it and run it. And that'll pretty much turn the result parentheses, and then you do 2.0, but just know math.pow will return you a number with a decimal. If you don't want the decimal, right before math.pow, you can put some more parentheses and type int in there. You can space it out if you want to, save it and run it. It's to decimals, so we can do just a number with a decimal. Say double exponent equals math.pow, and we'll say like 2, let's say 2 cubed to the power of 3, like that. And we'll just print that out to the screen, the exponent. Save it, run it, you get 8. Again, if you wanted to turn this into an integer, we'd replace this with int, and then put this int in parentheses in front of it. That turns this exponent into an integer. Save that and run that. You get it without the decimal. On one hand, it's helpful that they have it. On the other hand, it's kind of confusing, but I hope I was able to explain it clearly to you. If it was helpful, please share this. If you've ever wondered about the Java Math Library, then I have got the video for you. Today I'm going to show you what every single method in the Java Math Library does for you, so you can use them pretty easily instead of struggling through documentation like I did. How's it going? My name's Alex. I make Java tutorials on this channel every single week. I've got a lot of videos on my channel already, but if you're new here and it's something you might be interested in seeing, then consider subscribing. Whoopah! We're in Eclipse. Let's just make a new Java project by going to File, New Java Project. Call it Math. Math is fun. Hit Finish here. Right-click it and go to New Class. We'll name this, and then we'll start learning what those Math Library methods are. We'll just name it Math. Is cool. If you name it just Math, I think that might cause some errors in your program. It might be confused between the class name and the package for Math, but just try to name it something different. Click this public static void main checkbox and then hit Finish. The Math library in Java is just a bunch of Java code that they wrote for us to make it easier for us to do math, like calculate exponents, cosine, tangent, things like that. And it's built into Java, which is pretty great. So to start using it, to start using all those magical math functions that they have, we're just going to type math dots to bring up everything that the Math library can do. And I'm going to go through every single one of these. I'm going to go in order, alphabetical order. So if you have one that you're really interested in learning about, then you can skip to that section of the video. But we'll start by doing math.class and throwing that in a print statement. We'll print out math.class, see what that does. And that just brings up class, java.lang.math. This is a variable inside the math library that tells you what class it is and where the corresponding code is. We'll move on to the next one, math.e.
I guess I need to restart the Visual Studio Code again. When it does things funny, I will need to restart. Okay, let me share again. Share this window. Okay. Let's try to run it. Okay, it finally comes back. Let me try. What does the math.class give me? Extra class java.lang.math. Okay, that's
Math.e will print out that magic value e, which is very useful in calculus.
Magic e
and other areas. And so
Okay,
that set says 2.7182818. So every time you need to use that variable, instead of typing it out,
pi.
you can just call math.e. Next, we've got math.pi. And this is the same thing. It has pi in there for you, rounded to 15 decimal places. And if you hover over it, you can see the type. And you see here that this variable is a double, which can hold a lot of decimal places. It is very useful for numbers like pi. So you can use this for your circle calculations if you need to. Let's move on to the next one. Looks like we're done with all the variables here. How I can tell that is by these little icons. So the tiny ones are values, and then the big green circles look like methods. So I'll click abs here, and this is the absolute value. So you can do math.abs to calculate the absolute value of something. So say -12. If we do that, then we'll see the absolute value is 12. If we do like +18, then the absolute value will be 18. This will work with decimals as well, 18.2, 18.2. And that's actually why, we do math. Again, that's why you see 4 different absolute value functions here. One for double, one for float, one for int, and one for long. Those all do the same thing. Gives you the absolute value. Trucking on along, we've got acos. What could that do? Well, that's actually the cosine of a value, like 0.54. And I'm sorry, not the cosine value, the arc cosine value. And it will return the angle for you between 0 and pi. If you put in a number here that's outside of the range between 0 and 1, so like 1.1, it'll return NaN, not a number. It can actually be between -1 and 1. So any number between that range will work. So that's acos, arc cosine. After that, we can move on to add exact. This will add numbers for you and eliminate rounding errors. It works for both the integer values and long values. Moving on to asine, arcsine, any value between -1 and 1 will work. Arctangent is the same thing. It will return the arctangent for you, like so. Atan2 is arctangent squared. This is the angle of an xy point and the positive x-axis. So we can say there's a point in space that's like 6, 3, and we get the angle. It converts those rectangular coordinates xy into polar coordinates r theta for you. After arctangent squared, we've got CBRT. That's the cube root. So if we put a 9 in there, save it and run it, then we get 2.08. Let's see what else has a cube root. I know that 8 does. 8's cube root is 2, and there we get 2. Next, ceil. This is very useful because it will get the ceiling value of whatever you put in. So if I put 2.3, that will return a 3. It will round it up, and that can be very useful. This one is overcomplicated, I think, and it just takes the sign of the second number and puts it on the first number. So if we say like positive 4 and negative 2, then it gets negative 4. It takes the sign of the second number and puts it on the first. If this was positive and then negative, then we'd get positive 4. That works for both doubles and floats. Cos is the cosine between negative 1 and 1. Like so. You put in your angle in radians, and it'll return the cosine for you. Cosh will return the hyperbolic cosine, and it's defined by this formula right here. So you can get the hyperbolic cosine of your number in radians, like that. This is really great because you don't have to calculate it all in Java. It just does it for you. That's actually extremely convenient. Decrement exact will decrement the value by 1. So if I can do 9, and it will give me 8. That works for both integers and longs. By the way, if you're a little confused on the difference between longs, ints, doubles, and floats, you can see that on the screen now, where I go into in-depth on the difference between all 4 of those, once and for all, so you have no confusion. Exp is the variable e, that magic number e from earlier at 2.718 raised to this power. So if we raise it to the power of 1, then we get the original. If we raise it to the power of 2, then you get the idea. Exp m1 returns the value of this formula. So it's e to the x minus 1. So if we have e to the 1 minus 1, we should get like 1.718. Yeah, 1.718, because that's just e to the 1 minus 1. So you can use this to use pretty cool equations very simply through the math library. We've got floor. This is just like ceil, the ceiling, except we're going to round it down to the bottom. So if I have like 6.999, since it's on the floor, we're going to round it down to 6. Floor div is dividing x by y and then taking that value to the floor. So if we divide 5 by 2, the answer is 2.5, but since we're flooring it, the answer will spit out 2, like that. That works with both ints and longs. Floor mod will do x mod y and return the floor of that. So if I did 5 mod 2, the remainder is 1. The floor is 1 is still 1. So we get 1. Floor mod also works with both ints and longs. Get exponent will return the unbiased exponent of a number. And I honestly don't know what that is. But if we put in 64, then we get 6. And I guess that's the unbiased exponent. I'm sorry I wasn't too useful in that. I don't really understand that one too well. But that may be an off case if you need to use that one. That one works for both doubles and floats. Hypot will get the hypotenuse of an x and y value. 3 and 4 should return a hypotenuse of 5. So if we go 3 on the x, 4 on the y, hypotenuse is 5. It's a squared plus b squared equals c squared. 25 equals 16 plus 9. We have IEEE remainder. This is just like mod, except it uses this IEEE standard of calculating remainders. So if I put in like 5.4, 3.1. We'll calculate the remainder using that standard, and that's the remainder. It says the remainder is mathematically equal to the first value minus the second value times n, where n's the mathematical quotient, and that's the formula. Ooh, there are more than I expected. It was good for you. Good for the people using Math Library. Increment exact, this is just adding 1. So if we put 8 in there, it'll return 9. That works for integers and longs. We've got log. This takes the logarithm. So if we put math.e inside of here and take the log of e, then we get 1. Dude, my math, like being able to use calculus again is like, whoa. Moving on, log 10. This is the log base 10. Say like 12. We get the log base 10 results. Log 1p is the natural logarithm of the sum of the argument and 1. Math.max will return the maximum of 2 values. So if we have 98 and we have 222, then it'll print out the max, which is 222. Math.max will work for doubles, floats, ints, and longs. Math.min here will get the minimum value. So if we have 3 and 5, it'll bring back 3. Math.min works for doubles, floats, ints, and longs too. Multiply exacts. We'll multiply these two numbers exactly. 2 and 3 is 6. The difference between regular multiplication using the asterisk, regular subtraction, and regular division, all that. The reason why there's math.multiply exact is because it'll throw an exception and tell you if the value overflows. That's the only difference there. You know, I think regular ones do that too. I can't remember. Might just be more organized that way. Multiply exact works with integers and longs. Negate exact. This will take this value and turn it negative. If you put a negative number in here, then it'll come back positive, since 2 negatives make a positive. That works for integers and longs. Next, after, so I started looking this one up, and I can't actually figure out what this one is. A float is your start, and a double is the second one. So it looks like the first number goes down a few floating point values based on the second number. If anyone in the comments knows about this one, please let me know in the comments to help some other people out if they want to use next after. But it looks like it's mostly just the first number down a few floating points based on the second number. Sorry for that. That one was a little confusing. That works for both double double and float double. We have next down, which gets a few floating point values down. That works for doubles and floats as well. Next up, these are all very similar. I'm starting to see a pattern here. We do 53. Then we get a few floating point values up. We're almost done, everybody. Almost done. We've got POW. This calculates exponents. We can do 3 to the power of 4. That's 81. 2 to the power of 3 is 8. Random, this will generate a random number between 0 and 1. Our int will turn a double value into an integer. It'll do the closest one. So if it's 4.3, it'll go down to 4. If it's 4.6, it'll go up to 5. Rounds will do the same thing. It'll round up or down. So this one should round up to 7. 4999 will round down to 6. That works for both doubles and floats. Scal B will return a number D times 2 to the scale factor. So if we have a number 2, this will be 2 times 2 to the power of 1 will bring 4. So we got 4. If we want 3 times 2 to the power of 2, that'll be 3 times 4, which is 12. So we'll just return that equation answer. That works for both doubles and floats. Signum will return the significant number. So if it's positive, it'll return 1. If it's negative, it'll return -1. And if it's 0, it'll return 0. Sign will return the sign between -1 and 1, just like before. We're very used to these ones because there's a lot of these in the math library. Next in the Java math library is sine h, which is the hypotenusal sine. So we can do the same thing, and we get the sine hypotenuse. Sorry, hyperbolic sine. I sounded like an idiot. Hyperbolic. Squirt will get you
Hyperbolic.
a Squirtle Pokemon for free. No, it's the square root of a number. Got 9, return 3. Subtract exact. We'll subtract the two numbers.
Exact.
Say, subtract 9 and 2, we'll get 7. That works for integers and longs. Tangent will bring you the tangent, just like the other ones.
Tangent.
Tan h will bring you the hyperbolic tangent.
Hyperbolic.
2 degrees, you'll put in your angle in radians, and it'll convert that to degrees. So 0.45 in radians is 25.78 degrees. Next, we've got 2 int exact. This will convert it to an integer, but it has to be a long in here. Whoa. Long in here. Oh my gosh. The long in here. Yeah, it'll convert a long to an integer for you. If it's high, it'll just round down. Just a few more left. We've got 2 radians. You put your angle in degrees here. Say 90-degree angle is equal to 1.57 in radians. Ulp, I believe, will return the difference between a double and a float. So if you put in 6.4444, then it gets the difference. Here, let me try to bring up what it says for you. An ULP, unit in the last place of a double value, is a positive difference between this floating point value and the double value next larger in magnitude. So if you want to use this formula, then you can do that with the ULP method. And finally, the last in the Java, that was it. ULP are the last ones in the Java math library. Just going to put in my favorite one here. I really like the math.random. Super nice, super useful. But that was every method in the Java math library. We went through E, pi, which are the sort of mathematical variables you use all the time. We've got absolute values. They've got trigonometry in here, exponents, floors, hypotenuse, hyperbolic cosine, mins, maxes, scaling values, converting to degrees, converting to radians, and all these wonderful things inside the Java math library. So if you think that this was helpful, please leave a like. I make Java videos this all the time, so you can check much more. I think I have like...
Okay, browsed through the math library. Yeah, there is like tangent, like degree to radians, arc to like tangent, sine, cosine, E, pi, square root, power. I just want to check out the random methods. This is super useful. Random, like give it a name, equals to new random. So you will need to import java.util.random, this class. So integer r equals to rand.next integer, which will give us which will generate an integer that is fortune.length, that is fortune.length is 1, 2, 3, 4, 5, 6, 7, 8, 8. Means it will generate between 0 to 7. 0 to 7, right? Let me try. 3, 0, yeah. It will generate through 0 to 7. 5, 0, 5. Give me a 7. Yes, 7. 7. Then there is no 8. Yep, so next integer, give it an integer. Here is 8 because fortune array, the length of the fortunes array is 8. So it will give you an integer from 0 to 7, not including 8. Then you can do it, you can use it to whatever. Okay, let me see what time is it now. So I didn't really write any code today, but it's okay. I upload an assignment to the GitHub earlier, so I did wrote something today. Yeah, I think that's all for today. Okay, I'm going to are there people here? Oh. Are you ready? Can you hear me? Chris. Okay. Okay then. That's all for today. It's 9:23 p.m. I'm going to make a call and going to sleep soon. Bye bye.